thinking about from Math 17A, anytime that I have a sequence where I'm getting to the next number by multiplying by a constant value each time, that's what defines a geometric sequence. And our textbook actually gives a formula for the nth partial sum of a geometric sequence, which means when I'm looking at problem 1D from discussion sheet 2, that problem looks like 1.2 to the 6th plus 1.1 to the 7th plus 1.1 to the 8th plus 1.1 to the 9th. And that keeps going all the way up to 1.1 raised to the 200th power. So in order to evaluate this sum, we're going to want to use the formula for a geometric series. This first term, it's kind of an outlier because it's not following the pattern for the rest of the terms. So I am actually going to keep it by itself and have 1.2 to the 6th. For the remaining terms, in order to make it match up better with our formula, with a power that's starting at 0, I'm actually going to factor out 1.1 to the 7th from all of the terms. And if I factor out 1.1 to the 7th, then that first term would just be, this is what I'm calling now my sort of first term. That would be 1. That next term would be 1.1. The 1.1 to the 9th would actually look like 1.1 squared, again, because I factored out the 1.1 to the 7th, which means that when I get to that last term, it won't be 1.1 to the 200th because I've pulled 7 of them out. It'll be 1.1 to the 193rd power. Now it's a matter of rewriting this with summation notation to use our rule. So I've got 1.2 to the 6th plus 1.1 to the 7th. And then this, if we rewrite in our summation notation, I'm going to start at 0 and go to 193. And each of these terms can be written as 1 times 1.1 raised to my indexing variable. And I'm just using I right now because that's what we've been using for our Riemann sums. And then this part, we're going to replace using the formula. So I'd have 1.2 to the 6th plus 1.1 to the 7th. And then this would turn into 1 times 1 minus, now our R here is 1.1. So 1.1 raised to the n, which is 193, all divided by 1 minus 1.1. So it's terribly messy and doesn't have a ton to do with what we're talking about right now, except that Riemann sums are one example of a summation. And I think this was on the discussion sheet, just to remind you that we actually have seen some of this summation before, but we saw it in the context of 17A.